for the long weekend. Yeah. Okay, we're gonna start with the peripherally acting antitussives, because for the cough is the drug that may manage to control the cough. They have two parts together. First is the central part, and the second one is the periphery. Periphery is the one I'm going to talking about, is the effect to the cough reflex. Because the cough reflex is right here, is below the brain, right here, and have the receptor or the one that sensor to the cough center from the pharynx or the larynx, and some of them is in the upper respiratory tract. That's the two parts together. So, and the drug we're going to use to control the cough from the peripheral acting for that thing is just like to reduce the production of the mucus, or to have the mucus change the structure. Because the mucus is very viscosity and very have like a sticky, so change the structure to be more liquidifying, so that can easy to expand it to the expirated. But the mucus is basically is just a produced from the epithelial cell on the respiratory tract already, because it just trap the foreign dust or the something from the breathing, and when they trap it, it's just like to expirate for the foreign body to outside the respiratory tract. But sometimes the goblet is have the two types to produce that substance. They have some substance is very liquidified, and some substance is not from the goblet. It from be like a dead cell or inflammatory cell, and that one is cause the viscosity of the mucus. And the important thing that make the mucus is more viscosity is the DNA and the protein from the inflammatory inflammation from the cell. That's why have a high of viscosity, going to be more mucus, and the lumen of the respiratory tract going to be narrowed down, and once narrowed down, they're going to initiate for the reflex of the cough center, and that cough is happen once the animal have the respiratory tract inflammation or infection or something wrong is a respiratory tract. The drug or the pharmacology are going to reduce the cough when that happens. The first is the mucokinetics. The mucokinetics is the drug to facilitate the removal of the secretion that improves the activity, the increased production, the one is more liquid for that. And then the more liquid going to be like from the more viscosity, going to be less viscosity. The drug can be the activate beta receptor on the respiratory tract, or can be like mutin-17 that gonna increase the lumen of respiratory tract. And this microkinetic substance, they can be any substance that to reduce the viscosity. First is the hydration. That can be just only the sterile water or like a pure water, or the solution that have increased the pH pH meter to the viscosity. Because from the inflammation happen is have a lot of the acid, because from the degranulation of inflammatory cell and have the more acidic, gonna less pH. And once you use the increased pH in the mucus gonna be break it down and have less viscosity. Or you can use a solution have the increasing ionic strength, like the high solution of the sodium carbonate or the saline. Or you can see from the human medicine, they use the saline to flush out from the upper respiratory tract. That's gonna be reduced for the mucus viscosity, gonna be and mucus gonna be expanded to the respiratory tract. And the other drug and we use for the microkinetics is N-acetylcysteine. As we know, we use for the antidote of the acetaminophen toxicity, if you remember that. And the N-acetylcysteine can do to reduce the mucus production because it's going to be break down to the sulfide bond. And the sulfide bond is happen when they have like some remnant or some like a less production of the DNA. And once the DNA have the information, they're going to accumulate and form the sulfide bond. And this drug going to be break down the sulfide bond, and the mucus going to be less viscosity. And the first, and the drug we use in a lot in the human medicine, but not a lot in the small animal, is the bromhexine. You can see from the OTC drug to help for the cold or some have a respiratory tract system. The bromhexine is made from the ricin alkaline and made from plant and gonna increase the lysosomal activity. And once they increase the lysosomal activity, they're gonna enhance the hydrolysis of mucoprotein in mucus. And that gonna stimulate to the goblet cell to secrete the more fluid. The dead fluid is not have the viscosity. And once they have the more fluid, the mucus is going to be less viscosity. But for the limitation of bromhexine, that's why we didn't use a lot in the small animal, because they cannot use from like a severe inflammatory inflammation from the respiratory tract, because from the severe inflammation, they're going to cause a lot of amount of the DNA. And that a lot of amount of DNA, the bromhexine, then not affect to the DNA content for that. That's why bromhexine is not common use in the small animal. As N-acetylcysteine, the one I mentioned earlier, is a derivative of amino acid L-cysteine. It have a mucolytic effect because they break down the sulfide bond. And also they have the anti-inflammatory effect because they can stimulate, or they have, N-acetylcysteine is a precursor of the glutathione. It's not only in the hepatocyte. That's why we use for antidote of the acetaminophen toxicity. But it also as a precursor from the glutathione in the lymphocyte, intracellular. That the glutathione is have anti-inflammatory effect. And also it have the paradoxical effect of the polymorphic nuclear cell. They stimulate the function of that, so the polymorphic nuclear cell, they can activate, they can engulf for the foreign body or the pathogen. They can use like a systemic, like an injection, or they can use it as a nebulizer. Nebulizer, they just have like a, have you seen the nebulizer before? Mm-hmm. Yeah, it's just like a cocktail, right? And that cocktail they have used oxygen and it makes like a vapor, and that vapor gonna be the fluid can be the normal saline or the beta agonist, because they're gonna increase the lumen, the diameter of the lumen or the bronchodilator, or they use the N-acetylcysteine in that cocktail to reduce the mucus production. And another group of to help the antitoxic is the expectorant, is the enhance the expulsion of secretion from respiratory tract, and is also is a liquefy and dilute viscid secretion. They acting directly to the goblet cell, because as I mentioned, the goblet cell is produce they produce a substance that is more liquidified and is help to trap the foreign body and going to be expect or the expel from the foreign body to the from the upper respiratory. But this drug is less commonly used in the small animals as well. But I will mention just a little bit two types of this substance is the iodide preparation or the guaifenesin. Iodide preparation is like the ancient drug they use as to irritate for the upper GI tract, and once they irritate the goblet cell, gonna secrete more liquid to the upper respiratory tract. Contraindication because the iodine, as we know, they can have the toxicity for the pregnant animal, hyperthyroid, and we cannot use for the animal that produce the meat produce or milk produce because they're gonna have like residue in the milk. And the other one is a guaifenesin, or we know as the robitussin, is the OTC drug. And this one is no change in volume or the viscosity of bronchial secretion, but may accelerate the particle clearance. We don't know exactly what is the mechanism of action for this drug. And for the miscellaneous respiratory drug, and we done for all that, but some of them we use, it's not the respiratory drug, but we use to treat the respiratory system. For example, furosemide. Furosemide they use in horses, especially for the horse, for the racing horse, because the racing horse they have like a hyperactivity for the racing program, and once gonna happen, they have the more prone to have the severe pulmonary edema or like a pulmonary and pneumonia from that. So to prevent that happen, they use the furosemide to reduce the pressure at the pulmonary artery. And the other group is a respiratory stimulant, and you will learn, I think you learned from the Dr. Josh, naloxone. Naloxone is a stimulate respiratory from the narcotic overdose, because once you use the overdose of the morphine, like they're gonna depress respiratory tract. And once they depress, you can counteract for this reaction by using naloxone. And yohimbine is used to stimulate respiratory duration once you use the psilocybin overdose. And the other one is the nosapram. Nosapram we use for the CNS stimulant to the increased respiratory tract function after anesthesia. For example, like you do the to help the animal, to do the C-section. Because the C-section you have to do anesthesia for the animal, right? And once the puppies they come from, they have the respiratory patient because from the anesthesia. You use the doxapram, just one drop by oral, and they're going to increase the respiratory function to the puppies. Any question before we go further? And yeah, we discussed about the nebulizer. It's just a local administration when the animal have the problem, especially the upper respiratory tract. Because advantage is enhanced efficacy because they have the local effect. Some of drugs, especially for the bronchodilator, they can have the adverse effect from the drug. And we can use just only the local effect by using nebulizer. And it's a rapid response, but the downside of the from the nebulizer is just have like a short period of time. And it doesn't have like 3 or 4 hours, but it cannot be like for the whole day. But once you use a nebulizer, you have to repeat like once a day or maybe twice or 2-3 times a day for the animal getting better, and then you decide to use the systemic treatment after that. And also factor influence for the airway, it depends on what type of nebulizer you use, because the nebulizer you use is important that because they're going to create the diameter of the droplet of the nebulizer. And that droplet can tell you the drug can go to which part of the respiratory tract. For example, like the nebulizer, they create like the higher diameter of the droplet. They're gonna have the effect just only to the larynx, cannot go to the bronchial. But the less diameter of the droplet can go further of the respiratory tract. Okay. And as I mentioned earlier, the one like a cocktail to use in the nebulizer, this is the commonly agent they use as a in a cocktail. It can be the bronchodilator, glucocorticoid, mucokinetic, or antimicrobials. Or some of the textbook or some of the practitioners they use alcohol, but I'm not prefer to use alcohol because the alcohol they're going to dry out of the respiratory tract, going to be cause more the problem because going to be dehydration and no water in the upper respiratory tract. Okay, any question before we start the GI tract? This one is just pretty straightforward. Okay. And it's time for the GI tract first because it's very important and is more commonly used than the anti-cancer or the immunomodulator. So that's why I pull out this one because I'm afraid I cannot finish for this in time. And before we get started for the GI pharmacology, we're going to talk about the learning outcome for the part 1. First, you need to know about the normal physiology of the appetite regulation because we're going to talk about the drug stimulate the appetite and describe the receptor and the location with the brain that are responsible for the protein emesis or vomiting. And describe the clinical effects and mechanism of action of prokinetics. I'm going to review a little bit about the normal physiology of the GI movement and separate the modulator of intestinal motility based on their anti-diarrheal properties and the complication that may occur in your patient. Basically, you need to know the normal physiology of the GI tract, mode of action for each drug, especially for the motor drugs, clinical indication, adverse effect. GI tract is just the complicated system because it starts from the brain and going down for the whole body system. So basically for the GI tract, the function is that just like to digest all the food intake from the food and digest to the small molecule. And when it becomes the small molecule, the GI tract going to absorb that content. And that content can be nutrition or the vitamin or water. So, and during that mechanism, they need to use an enzymatic, or they use a mechanism of the GI tract like to squeeze it out of the body, of the GI tract, and the regulation, the GI tract is regulated by the metabolic system, physiological system, or even nerve system. It's very complex. And it's a species independent because you cannot compare from the monogastric animal to the ruminant animal, right? Because it's just like a big difference of the GI system for these two of them. But it's not just like the two types of this classification. They have like a small detail for that thing. So I will go over real for that. And for this line, I would like to point out that you need to understand the normal physiological of the GI tract for the species, and then you will understand how the pharmacological management for each part of that. And for this line or this section, basically we're going to talk about like stop and go down. It's to make easier you to memorize the thing. First part is the appetite for the animal. Animal that only have the problem is a lost appetite. It's not like in human, right? Because in human they always have like more appetite than the normal. But for the animal have the chronic disease, they can have like a less appetite, and we would like to increase the appetite. So the only group we're gonna talk about this is the appetite stimulant. And emesis, we're gonna talk about both parts is like a stop and go. Stop is the anti-emetic, because some serious problem, animal can have the vomiting, and vomiting is going to create a lot of problem follow from that, because it's going to be loss of electrolyte, dehydration, or acid-base imbalance. And some animal, they ingest some suspect toxicity, so we use emesis to prevent the absorption of the toxin for them. And for the lower GI motility, we're gonna do two parts together. Like from the treatment, the diarrhea, we're gonna stop the movement from that, right? And the one have the problem with the constipation, we're gonna increase the movement of the smooth muscle GI tract by using the prokinetics. This is the list of the mode drug from stop and go. The red is stop and the green is go. Is for the one I underline, you need to know everything about that. That means include like a mechanism of action, therapeutic indication, adverse effect, and what else? Yeah, everything you know. But in the parentheses or the not underlined, it's just you need to know for the unique property about that. First is the appetite stimulant. Some the chronic condition, for example, the animal have the chronic renal disease or they have